Welcome to today's deep dive. Our mission today takes us straight into a pretty massive stack of historical notes and, some Wikipedia data to uncover the story of a true mechanical behemoth.
Oh, absolutely. It's a heavy one.
Yeah, literally. We are looking at the German Empire's very first operational tank, and incredibly, the absolute only one they produced and actually utilized in combat during the entirety of World War I. So we're diving into the history, the engineering, and just the sheer chaos of the A7V.
It really is a remarkable piece of history. I mean, it perfectly illustrates how industrial warfare completely transformed in just, a few short years.
Right.
Because, as you probably already know, the grim reality of the Western Front's tactical deadlock by 1916 was it was bleak. The static, muddy trenches had essentially frozen the conflict in place.
Just miles of mud and barbed wire.
Exactly. But the moment those British Mark Series tanks rolled across the mud in September of that year, literally ignoring the barbed wire and machine gun fire that had kept infantry pinned down for months, that static warfare just shattered.
I mean, the psychological shock of seeing these armored fortresses crawling toward your trenches, shrugging off rifle fire, it completely changed the calculus of the battlefield.
Yeah, the panic on the front lines traveled up the chain of command almost instantly.
Which is wild because up until that point, the German high command had shown very little enthusiasm for armored vehicles. They had seen some early proposals, but offered almost no funding.
Right, they basically ignored it.
Yeah, but the appearance of the British tanks forced an immediate and desperate pivot.
Okay, let's unpack this. Because the German War Ministry suddenly realizes they're incredibly far behind in an entirely new category of warfare. How does a massive military bureaucracy attempt to close that gap overnight?
Well, they default to what large bureaucracies do best, right? They form a committee.
Classic.
Yeah. And specifically, they handed the problem to a department whose name sounds entirely unrelated to cutting-edge weaponry. In German, it was the Allgemeines Kriegsdepartment, Abteilung 7 Verkehrswesen.
Which translates to the General War Department, Section 7, Transportation.
And for anyone listening who's wondering where this legendary tank gets its snappy acronym, that unwieldy bureaucratic title is the source. Abteilung 7 Verkehrswesen simply becomes the A7V. I mean, they essentially named their terrifying new weapon of war after a transportation subcommittee.
It's a rather mundane origin for such an imposing machine, isn't it? But this committee had a remarkably urgent job. By December of 1916, they finalized their requirements and handed them over to Joseph Vollmer, who was one of Germany's foremost automobile designers.
Right.
And the blueprint they gave him was essentially a wish list for military dominance, drafted by men who had never built a tank.
What did they want it to do?
Well, they demanded a 30-ton vehicle. It needed to be capable of crossing ditches up to 1.5 meters wide. It had to hit a top speed of at least 12 kilometers per hour. And initially, they wanted it heavily armed with cannons facing both the front and the rear, supplemented by multiple machine guns.
So they're handing an automobile designer a blank sheet of paper and asking for a 30-ton landship on a tight deadline. I mean, that meant Vollmer had to cut some serious corners, right?
Oh, absolutely.
Like for the chassis, the running gear, and tracks of the tank, he didn't invent an entirely new system. He looked at what already existed and heavily borrowed from the design of the American Holt tractor.
Yeah, that's a crucial detail.
I read that the engineering team actually sourced examples of these Holt tractors from the Austro-Hungarian army just to reverse engineer the tracks and suspension systems so they could handle the immense weight they were planning.
What's fascinating here is how the German command originally envisioned this entire production run. When Vollmer was working on the blueprints, the overarching design philosophy was to create a universal chassis.
Like a modular system.
Yes. The military wasn't just building a tank. They were attempting to build a modular base platform. So out of the initial order of 100 chassis, the High Command eventually decided that only 20 were going to be finished as the heavily armored fighting vehicles we know today.
Wait, so if they ordered 100 of these massive chassis, why did only 20 actually make it onto the battlefield as armored tanks? Was that like a production failure or a specific strategic choice by the War Ministry?
It was absolutely a strategic choice. It was driven by the desperate logistical realities of the German war effort. The remaining 80 chassis were purposefully designed to be unarmored cargo carriers.
Ah, okay.
They designated them as Überlandwagen, which translates to overland vehicles. The German army needed heavy supply carriers capable of navigating ruined terrain just as desperately as they needed frontline weapons. So the armored A7V tank we are examining today was actually the minority variant of his own production run.
That's wild. The military prioritized logistics over armored assault.
Exactly.
Well, that focus on logistics makes sense given the strain on their supply lines, but let's look closely at those 20 chassis that did get the armored treatment, because the physical presence of this machine is staggering. To give you a sense of scale, the A7V was 7.34 meters long. That's over 24 feet.
It's massive.
Yeah, it was over 3 meters wide and 3.3 meters high. If you stood next to it, the roof would tower over a single-story house. It was a massive moving steel box. And the armor plating wasn't uniform, right? They slapped up to 30 millimeters of hardened steel on the front.
Right, which was thick enough to easily shrug off standard infantry fire and even some light artillery shrapnel, though the roof was much more vulnerable at only 10 millimeters thick to save weight.
But the exterior dimensions were just, the internal layout is what makes the A7V truly unique and, honestly, from a human perspective, incredibly grueling. The crew requirements were just unprecedented. Officially, the A7V required a minimum of 18 men to operate a single vehicle.
18 men in that box.
Cramming 18 men into that space is less like a traditional tank crew and more like trying to operate a small naval vessel inside a sealed iron boiler. How do you even divide the labor among that many people inside a single vehicle?
Well, the division of labor was strictly defined, even if the physical space wasn't. You had an officer commanding the vehicle, typically a lieutenant. You had a driver responsible for navigating the massive chassis. You needed 2 mechanics actively monitoring the engines, one of whom doubled as a signaler.
Okay, so that's 5.
Right. And to operate the main cannon at the front, you had 2 artillerymen, a gunner, and a loader. And finally, 12 infantrymen were packed inside to operate the secondary weapons, acting as 6 machine gunners and 6 loaders.
Just shoulder to shoulder in there?
Exactly. And that was just the official manifest. During actual combat operations, crews were known to bring extra men along, sometimes cramming up to 25 individuals inside the hull.
Imagine 25 men sitting inside a steel box that has virtually no ventilation, positioned directly above 2 massive gasoline engines. The heat radiating off the engine block, the fumes from the exhaust, and the cordite from the fired weapons, the deafening mechanical roar, the sensory overload must have been paralyzing.
It would have been an absolute nightmare.
Communicating orders over that noise would have required shouting at the top of their lungs or just relying entirely on physical taps and hand signals. And they weren't just passengers, they were managing an overwhelming amount of firepower. Here's where it gets really interesting. Let's look at the actual armament they were deploying from this iron box.
No, the secondary firepower alone was devastating. The sides and rear of the A7V bristled with 6 7.92 millimeter MG-808 machine guns. The infantrymen manning these stations had to manage a staggering amount of ammunition. The tank carried between 40 and 60 cartridge belts of 250 rounds each.
Wow.
We are talking about up to 15,000 rounds of machine gun ammunition packed into an already overcrowded, highly combustible space.
And then there is the primary weapon. Mounted right at the front of the tank was a 5.7 centimeter Maxim Nordenfeldt cannon. Officially, the crew was supposed to carry roughly 180 shells for this main gun, a mix of canister, armor-piercing, and high-explosive rounds.
Which is a lot of heavy ordnance.
Yeah, but just like the crew capacity, the official limits were often ignored. Crews regularly stashed up to 300 heavy artillery rounds inside the cabin before rumbling toward the front lines. But the origin of these main cannons highlights a massive vulnerability in the German production pipeline, doesn't it?
It really does. It reveals the intense strain on German manufacturing at the time. The grand irony of the A7V is that its primary offensive weapon wasn't even German.
Right.
Many of those 57mm front cannons were captured enemy guns. The German army utilized British cannons they had seized in Belgium during the opening months of the war. Later on, they integrated Russian-made copies of those same guns that were captured on the Eastern Front.
So you essentially have the German Empire's flagship armored vehicle rolling into battle, relying on captured British and Russian weaponry to punch through enemy lines.
Yes. The supply chain was so fragmented that some A7Vs, like chassis number 504 named Gretchen, were initially built with just 2 forward-facing machine guns and had to be awkwardly retrofitted later to carry the 57mm cannon.
I imagine that fragmented production inevitably bled into the engineering quality, too. For all its heavy armor and immense firepower, the A7V carried some fatal design flaws that made it incredibly dangerous for its own crew to operate.
It did. The propulsion system was really the heart of the problem. The tank was powered by 2 centrally mounted Daimler Mercedes 4-cylinder petrol engines, each outputting about 101 horsepower.
Okay.
On a paved road, these engines could push the 30-ton vehicle to about 15 kilometers per hour. That was surprisingly fast compared to the heavy Allied tanks of the same period. It also featured an individually sprung 24-wheel suspension system, which theoretically provided a smoother ride than the unsprung rigid tracks of the British designs.
Theoretically.
Right, theoretically, because those advantages completely evaporated the moment the A7V left solid ground.
And a World War I battlefield in 1918 is the furthest thing from solid ground. I mean, the terrain is a pulverized moonscape of mud and craters. How did that suspension and propulsion system actually handle the realities of the Western Front?
Very poorly. The A7V had an extremely high center of gravity, a massive armored overhang at the front, and incredibly low ground clearance. This combination made the vehicle highly prone to overturning on steep slopes or crater edges.
Just tipping right over.
Yeah. Deep trenches or heavily churned muddy fields were practically impassable. The tank would simply bottom out and get stuck. Furthermore, the architectural design of the hull placed the driver high up and relatively far back from the nose. This created a massive blind spot.
How big of a blind spot?
The driver could not see the terrain for a full 10 meters, roughly 33 feet directly in front of the vehicle.
When you realize the driver had a 33-foot blind spot, it completely changes how you view their combat operations. The commander is trying to spot targets and navigate a chaotic battlefield, desperately signaling a driver who is effectively steering a 30-ton box of explosives blind into heavily cratered terrain.
It's an absolute recipe for disaster.
Which becomes painfully clear during their combat debut on March 21, 1918, near the St. Quentin Canal. The German High Command finally unleashes their secret weapon, and the results are, well, incredibly underwhelming.
Underwhelming is putting it mildly. The debut highlighted every mechanical failure we just discussed. 5 tanks from detachment were ordered into action. Before they could even engage the enemy, 3 of those 5 vehicles suffered catastrophic mechanical failures and broke down.
Wow. 3 out of 5.
Yes. The remaining 2 did manage to lumber forward and help stall a minor British breakthrough, but their tactical impact was negligible. It was a deeply anticlimactic start that proved just how unreliable the platform was under combat stress.
But the narrative shifts dramatically just a month later, right?
So,
On April 24, 1918, during the Second Battle of Villers-Bretonneux, the A7V secures its place in military history. This engagement marks the very first tank-on-tank battle ever recorded.
it does. The tactical situation at Villers-Bretonneux was ambitious. The German command assigned 3 detachments of A7Vs to spearhead an infantry assault across a 4-mile front. Unsurprisingly, reliability issues struck again, and 2 tanks broke down before reaching the assembly area.
Typical.
But 13 A7Vs successfully made it into action. As the assault progressed, 3 of these German tanks, including chassis number 561, commanded by 2nd Lieutenant Wilhelm Biltz and named Nix by its crew, were advancing through the fog and smoke when they unexpectedly converged on a position held by 3 British Mark IV tanks.
It's just a profound moment in the evolution of warfare. For the very first time, an armored force pushes through the fog of war and realizes they aren't facing soft infantry targets, but an opposing armored force staring right back at them. The psychological shift for the crews inside must have been jarring.
The historical records give us a remarkable blow-by-blow account of the tactical choices made in those crucial minutes. The British formation consisted of 2 female tanks and 1 male tank.
We should clarify that.
Right. In the nomenclature of the time, female tanks were armed exclusively with heavy machine guns intended for anti-infantry roles. The male tank, commanded by 2nd Lieutenant Frank Mitchell, carried 2 heavy 6-pounder cannons in its side sponsons.
Those female British tanks quickly found out that their machine guns were entirely ineffective against the 30mm frontal armor of the A7Bs. Even worse, the armor-piercing rounds fired by the German MG-08s were successfully penetrating the thinner hulls of the British Mark IVs.
Yeah, it was a bad matchup for them.
Taking heavy internal damage, the 2 female British tanks were forced into a rapid retreat, leaving Lieutenant Mitchell's lone male tank to face 3 advancing A7Bs.
The tactical disadvantage was severe, but Mitchell held his ground. Recognizing that machine guns were useless, he focused his 6-pounder cannons on the lead German tank, the Nix.
And this is where the A7V's flaws really hurt it.
Yeah, exactly. Yeah. The maneuverability crisis we discussed earlier played a massive role here. Biltz, commanding the Nix, struggled to position his heavily restricted top-heavy tank to return effective fire. Mitchell managed to score 3 direct, devastating hits on the Knicks.
Ouch.
The kinetic impact and internal damage from those 6-pounder shells disabled the German vehicle. The crew was forced to execute an emergency evacuation from the crippled tank under heavy fire, and tragically 5 of Biltz's men were killed as they bailed out into the mud.
Seeing the Knicks knocked out so decisively, the remaining 2 A7Vs opted to withdraw rather than risk the same fate. Mitchell then pivoted his focus to the advancing German infantry, switching his cannons to fire case shot.
We should briefly explain case shot for anyone unfamiliar with the term.
Yeah, Mitchell essentially swapped out his solid armor-piercing shells for rounds filled with hundreds of metal balls. When fired, the cannon acts like a giant shotgun, spraying shrapnel across a wide area, devastating against exposed troops.
Exactly the right tactic for the situation. Mitchell routed the infantry advance before his own tank sustained track damage from an exploding mortar shell, forcing him to abandon the vehicle.
That single engagement proves that armor could defeat armor, but the skirmishes didn't end there. Later that afternoon, another A7V engaged a completely different class of British armor, a group of Whippet tanks.
Right.
These were much lighter, faster medium tanks designed to exploit breakthroughs. The heavier A7V managed to successfully target and destroy one of the Whippets before the British retreated. As for the disabled tanks scattered across the battlefield, the Knicks was eventually coaxed back into motion by its surviving crew, but it broke down completely before reaching German lines.
So they couldn't save it.
No. To prevent the Allies from capturing their technology, a German demolition squad rigged the Knicks with explosive charges during the night and completely destroyed it. Another A7V engaged in the battle, named Elfriede, suffered the exact fate the engineers feared. Its high center of gravity caused it to flip completely upside down into a crater. It was abandoned in no man's land and carefully recovered by French troops 3 weeks later for study.
Which brings us back to the broader strategic view.
So what does this all mean? We have this massive, terrifying machine that required immense resources and a 25-man crew successfully fighting the first armor engagements in history. How do we assess its ultimate impact on the outcome of the war?
If we connect this to the bigger picture, the A7V was fundamentally a failure of scale. The German Empire poured vast resources into designing this vehicle, yet they only ever produced 20 operational tanks.
Just 20.
Yeah. Fielding 20 tanks across the entirety of the Western Front is a statistical rounding error. It made practically no strategic difference to the wider war effort. The German High Command ultimately sidelined the armored program because their industrial capacity was already stretched to the breaking point, prioritizing U-boats and aircraft. They simply couldn't manufacture the raw materials or spare the specialized labor required to refine and mass-produce a flawed tank design.
The production numbers really highlight a staggering industrial disparity. While Germany struggled to field 20 A7s, the French industry successfully manufactured over 3,600 of their light, highly effective Renault FT tanks.
Incredible numbers.
And the British built thousands of their heavy Mark series tanks. Facing those numbers, how did the German infantry cope with the armored imbalance?
Well, they adapted by utilizing their enemy's success. The ultimate irony of the German armored effort in World War I is that they fielded significantly more enemy tanks than they do their own. Yes, the German army actively captured roughly 50 British Mark IVs that had broken down or been abandoned. They towed them back to their own workshops, repaired them, painted massive iron crosses on the sides to prevent friendly fire, and redesignated them as Butpanzer, or captured tanks. The German military relied far more heavily on salvaged British engineering than they ever did on the A7V.
That reliance on captured technology speaks volumes about the A7V's legacy. But what happened to these massive machines once the armistice was signed? Did the surviving chassis just get sent straight to the scrapyard?
Most of them were indeed scrapped by the victorious Allies in 1919 to comply with disarmament treaties. But their story didn't end immediately with the armistice. During the severe civil unrest in Berlin in 1919, a right-wing paramilitary Freikorps unit known as Kokampf desperately needed armored support. They actually located some of those unarmored Überlandwagen cargo chassis we discussed earlier.
Yeah.
The unit bolted heavy steel plates and machine guns onto the cargo frames to create improvised A7V-style vehicles, naming one of them Heidi, and used them to quell the uprisings in the streets of the capital.
I've also seen claims floating around historical forums that the French government shipped a surplus of captured A7Vs over to Poland to fight in the Polish-Soviet War in the 1920s. Is there any truth to those rumors?
None whatsoever. It is a persistent myth, but modern historians have thoroughly debunked it. The archival records are incredibly precise. Every single A7V chassis produced during the war is fully accounted for in the documentation. Not a single vehicle was transferred to Poland.
That's pretty definitive.
Yeah, the accountability of those records also leads us to the final fate of the very last A7V on Earth.
Out of the original 20, there is only one lone survivor left intact today, chassis number 506. The crew had painted a grinning red devil on its armor and named it Mephisto. How did this specific tank manage to avoid the scrap heaps of 1919?
Mephisto survived through a combination of bad terrain and geographical isolation. During the massive armor clash at Villers-Bretonneux, Mephisto became hopelessly bogged down in a deep crater. The crew was forced to abandon it in the middle of no man's land.
Just left it there.
Yeah, because the area remained hotly contested, it sat there, rusting in the mud, for almost 3 months. Finally, in July of 1918, Australian and British troops secured the sector. Recognizing the intelligence value of an intact German tank, they attached steel cables to Mephisto and used 2 British tanks to physically drag the 30-ton behemoth out of the crater and behind Allied lines.
That must have been quite the operation.
It was eventually shipped to London, and from there it was transported all the way to Brisbane, Australia to serve as a war trophy.
And it remains there to this day. Mephisto is carefully preserved and sitting on display at the Queensland Museum in Australia. If you aren't able to travel to Brisbane, you can find a few high-quality replicas in Europe. The Tank Museum at Bovington in the UK houses a fantastic running replica called Schnuck, cleverly built using plywood and angle iron mounted over modern tractor engines.
That's a great piece.
It is. Meanwhile, the German Tank Museum in Munster displays a highly accurate static replica named Wotan. But Mephisto is the only authentic, battle-scarred original left in existence.
It serves as a tangible artifact of a deeply chaotic moment in military engineering. When you examine the massive steel plates of Mephisto, you are looking at the sheer desperation of an empire trying to innovate its way out of a losing war.
It truly is a remarkable journey. From the immediate panic of the German War Ministry rushing to form Section 7, to Joseph Vollmer attempting to build a 30-ton weapon on top of a tractor suspension, to the terrifying reality of 25 men trapped inside a deafening iron box fighting the first armor-on-armor engagement in human history. The A7V represents a monumental leap in military technology pushed to its absolute breaking point.
This raises an important question regarding the trajectory of that technology. Our source material details a few unfulfilled variants of the A7V that were actively in development when the war ended. The most prominent was the A7VU. The U stood for Umlaufende Ketten, which translates to tracks running all the way around.
So the engineers finally recognized that the British wraparound track design was superior for crossing the massive trench networks.
Precisely. They drafted a prototype with a rhomboidal hull mimicking the British Mark series, featuring wraparound tracks to solve the ground clearance issue. They also moved the heavy cannons away from the front, planning to mount them inside sponsons, which are essentially armored platforms protruding from the sides of the hull to improve the center of gravity.
Makes sense.
But the prototype they built in June 1918 was incredibly nose-heavy, weighed an astonishing 40 tons, and suffered from terrible maneuverability. They initially ordered 20 of them, but halted the project just months before the armistice. There was also conceptual work on a variant known as the A7V Flakpanzer. This was an experimental anti-aircraft platform where engineers planned to reposition the engines and mount heavy, captured Russian 76mm field guns directly onto the chassis.
The visual of a 40-ton, heavily armed, rhomboid A7VU crashing through the trenches is a fascinating scenario to picture. It is a stark reminder of just how rapidly the core concepts of armored warfare were evolving, even as the German Empire's industrial capacity was collapsing around them. We'll leave you to ponder how the integration of wraparound tracks or mounted 76mm field guns might have radically shifted the armored doctrines of the 1920s and 30s had those engineers been given the time to refine their designs. Thank you for joining us on this deep dive into the origins of German armor. Keep questioning the established narratives, keep exploring the hidden mechanics of the past, and we will catch you on the next deep dive.